Dear students, welcome to the lecture series on the topic Engineering Graphics. So today we are going to discuss about Theory of Projections. I am Dr. IPS Ahuja, Professor Mechanical Engineering, Punjabi University, Patiala. Now first of all we need to understand what do we mean by projections. So projection is the image of the object formed by rays of sight from the object to the picture plane as it appears to an observer which is stationed at a point. So here you can see, in order to obtain a projection we need three things. The first thing is we need to have an observer. The observers will create the rays of sight or the rays of light, which are called the projector lines or the projection lines. So these rays of sight, they will be falling upon the object, and in turn they will be projected upon this plane of projection, and the intersection of these rays of projection with the picture plane is going to create the projection or the image of the object onto the picture plane. So this projection, it is also referred to as view by the technical people. So we are going to have multiple types of views. If we are looking from the front, the view obtained will be called front view. If we are looking at the object from the top, the view obtained on the horizontal plane will be called as the top view of the object. And if we are looking at this object from the side, so the view obtained on the profile plane, it will be called as left side view or the right side view of this particular object. So object remains the same, whereas we can have the multiple views of this particular object. So the plane on which this projection is made, it is called POP or a picture plane. So this is the picture plane onto which the image or the view of the object will be formed. And there are three types of picture planes that we are going to study during the course of this particular subject. So these picture planes will be vertical plane as it is shown into this picture. It can be the horizontal plane if we are going to look at the object from the top, or it can be the profile plane if we are going to look at this object from the side. So three types of picture planes we are going to take care of in this particular subject. And the point from which the observer is assumed to view this object, it is called the station point or the center of the projection. So over here into this picture, the center of the projection is lying over here, and the lines of sight, they are called the projection lines or the projectors. So here you can see these are the lines of sight. These are also called the projection lines or the projectors over there. And the lines of the sight of the observer, they create the view of the object on the screen. So wherever these lines of sight, they intersect with the picture plane, it is going to lead to creation of the image or the view of the object onto the picture plane or the plane of projection. Then the next is the basic projection theory. So in the projection theory, basically it is used to graphically represent 3D objects onto the 2D media, that is the drawing sheet or the computer screen. So there are basically two different projection theories which we are going to study. The first projection theory, it is based upon the line of sight, that is whether the lines of sight or the rays of sight, they are parallel to each other or they are converging at one point. So whatever we are able to see with our naked human eye, so those projections, they are converging at one point and they will be called as perspective projections. Whereas those lines of sight which are parallel to each other and perpendicular to the plane of projection, so those projections, they are called parallel projections. So basically during the course of the subject, we are going to talk mainly about the parallel projections rather than the perspective projection. So we are going to see what are the limitations of perspective projection which make them less attractive to draw the engineering drawings. Then the second method of the projection theory is based upon the plane of the projection, that is the image plane or the picture plane, that is in which quadrant we are going to assume our object to be lying in. If the object is lying in the first quadrant, we call those projections as the first angle projection. If the object is assumed to lie in the third quadrant, then those projections will be called as third angle projections. Then let us start with the first method of the projection theory, that is based upon line of sight. So a line of sight, it is an imaginary ray of sight between an observer's eye and an object. So as I have told you, there are two types of lines of sight. One type of line of sight is parallel line of sight, and the second type of lines or the projection lines, they will be convergent type. Now in the parallel projection method, we assume that the observer is located at the infinite distance, and all the projection lines, they will not have any convergence effect, and they will be all parallel to each other because the observer is at the infinite distance, and they will be parallel to each other, and they will be perpendicular to the plane of projection. So that way, this distance between the object and the observer is not going to affect the size of the object or size of the view or the image that we are going to realize. So irrespective of this distance of the object from the observer, we are going to realize the same shape of the object or the image or the view. So this is the actual method through which we draw all the projections into our engineering drawing. But another method is what we see as a human being, that is perspective projection or the convergent projection. Because you see, our rays of sight, they are focused through the retina, through our eyes. So what is happening over here? All the rays of sight, they are going to converge into our eyesight or into our retina. So over here, the limitation is, if there is any object which is closer to the source, that is which is closer to the observer, so that object will start appearing to be very big, and in case the observer is at a larger distance from the object, the observer will be viewing that object in a smaller way. So in this case, the distance of the object from the observer is going to decide the actual size of the object which is going to be drawn in case of any image or any view. So which is not desirable, because we do not want that the actual size of the object should be depicted by the distance between object and the observer. It should not have any bearing. So whatever the size of the object has to be obtained through manufacturing, same size of the object should be drawn onto the drawing sheet. So this is how that this type of projection, that is the convergent or the perspective projections, they are not found to be suitable for drawing the manufacturing drawings for the engineering constructions or the fabrications. So here you can see, here you have got the parallel projection over here. So in this parallel projection, you can see all the rays of sight, they are coming from the observer, and they will be passing through this object, and wherever the point of intersection with this plane of projection is obtained, this is going to give us the realization of the image or a particular view of the object. So here you can see, whatever is the size of the object, same size of the object has been drawn onto our drawing sheet or onto our plane of projection. Whereas in the perspective projection, now the distance between object and the observer will decide that how much is going to be the size of the object which my projector lines, they are going to create on my plane of projection. So here you can see the object is bigger, but I am able to see a smaller object. Reason, because it is at a reasonably large distance from the observer. Had this object been closer to the observer, so obviously large size of the object would have been drawn over here. So if we talk about the perspective projections, the projections, they are obtained on a plane when the projectors, they converge at a point. This is the limitation of the human eye. So the objects which are closer to the viewer or the observer, they will be drawn bigger one, whereas the objects which are farther away from the viewer, they will be drawn smaller in size, which is not desirable. So we cannot allow the distance of this observer and the object to dictate the size of the image or the size of the view, but the actual manufacturing should be as per the size of the object only. So here all the parallel lines, they tend to converge at this particular point, so they don't remain parallel because of the limitation of this human eye. So the disadvantages of perspective projections, they are, that is, perspective projections, it is not used by engineers or manufacturers for manufacturing of parts. Why? Because it is first of all difficult to create, and most importantly it does not reveal the exact shape and size of the objects. Whereas on the other hand, you can see the parallel projection is there, where the center of projection is at infinity, that is, the observer is located at the infinity. All the rays of projection, that is, all the projection lines or the projectors, they are parallel to each other. There is no effect of any convergence. Now even if this object, if we move towards the observer or farther away from the observer, it will not have any effect on the size of the drawing which is obtained on any given plane of projection. So this is what I was telling you. If we are going to look at the object from the front, the view will be obtained on the vertical plane, and this view is called front view of the object. Similarly, if we are going to view the object from the top, then the view obtained from the top upon the object, and this view will be obtained on the horizontal plane. This is HP or the horizontal plane. So this view is called top view of the object. Similarly, if we view this object from the side, the view obtained on the profile plane will be called the side view. Since we are viewing from the left hand side, so the view which will be obtained on the profile plane will be left side view. So here you can check that the size of this object and the size of this image, they are both the same. So there is no effect of any convergence whatsoever which is obtained on the view or the image of the object onto any given reference plane. So if you are looking from the front, this is the L shape which we are able to obtain. You can see this is the L shape we have obtained as a front view. If we are going to look from the top, this is one square we'll be able to see. This is the second rectangle we'll be able to see. So this is square part over here. Then this is the second part, that is the rectangular length of this particular object we are able to witness over here. So this way the top view is obtained on the horizontal plane, whereas the front view of the object is obtained on the vertical plane. So the benefits of the parallel projections is that it represents the accurate shape and size of the object, and the distance of the object from the observer doesn't have any effect on the size of the image which is obtained. But the disadvantage is because here you can see multiple views they are drawn to represent the images of the object from front, top and side. So obviously it requires proper training and practice in drawing and reading these drawings over there. Then if we compare the perspective as well as the parallel projections, here you can see the size of the object is varying. It is not the same as the size of the object, but the size of image and object, they are different. But in case of parallel projection, they are the same over here. So this, in case of perspective, size varies inversely with respect to distance, so it doesn't look realistic, and the distance and angles, they are not maintained. And since the parallel lines, they are not remaining parallel because of this convergence over here. So these projection lines should have been parallel, but they no longer remain parallel because of the convergence limitation of the human eye. Whereas in the parallel projections, they are good for the exact measurements. Parallel lines, they remain parallel, and in certain cases when the faces, they are at some angle to the planes of the projection, only then the angles, they will not be preserved. Otherwise, if this surface is parallel to the plane of the projection, then this surface true shape will always be obtained on the plane of the projection. So these parallel projections, we also call them orthographic projections. So what do we mean by ortho? So ortho means 90 degree. We call these projections as orthographic projections. Why? Because these rays of projection, that is these projector lines, they are parallel to the plane of projection, and they are all parallel to each other. Basically they are perpendicular to the plane of projection. So obviously this will happen only when the observer is assumed to be located at infinite distance from the object. So these are multi-view orthographic projection method. Basically is there. It is a method for drawing two or more views of an object on the reference planes at right angles to each other. So, and what are those planes which are at right angles to each other? These are the horizontal plane, vertical plane, and the profile plane. So we will see the 3D representation of all these planes just in a while. And we call these projections as orthographic because ortho stands for the perpendicular, and in this projection all the projectors, they are perpendicular to the plane of projection and they are parallel to each other. So this is the main requirement or of the orthographic projections. So here you can see, as we say, these are multi-view projections. So obviously single view is not drawn or not produced to give you the complete details of the object. In multi-view projections we are drawing minimum two views, or in certain cases we are even drawing three views of the objects, and these views, they are front view, top view, and the side view. So here you can see this is the quadrant theory. That is, you have four quadrants over here. This is your first quadrant, this is your second quadrant, this is your third quadrant, and this one is your fourth quadrant. So the first quadrant will be, the object will lie in the first quadrant when it lies above horizontal plane and in front of the vertical plane. The object will lie in the second quadrant when the object lies behind the vertical plane but it lies above the horizontal plane. The object will lie in the third quadrant when the object lies below the horizontal plane and it lies behind the vertical plane. The object will lie in the fourth quadrant when the object lies below the horizontal plane and it lies in front of the vertical plane. And if the object lies in the first quadrant, the projections obtained, they are called first angle projections. When the object lies in the second angle projection, second quadrant, then the projection method is called second angle projection. When the object lies in the third quadrant, the method of projection is called third angle projections. And when the object lies in the fourth quadrant, the method of projection is called fourth angle projection. And we should all remember that projections, they are never drawn in second and fourth quadrant or fourth angle projection method. Projections are always drawn when we assume the object is lying either in the first quadrant or in the third quadrant. So we'll know about this reason in a little bit time. So when the object lies in first quadrant, we say that projection method is called first angle projection. So we are going to discuss about first angle projection method as well as the third angle projection method, whereas second angle and fourth angle projection method, they are not used to study the projection of the method. So the horizontal plane and the vertical plane, they make the four quadrants. So this I have already explained. The position of an object in the space is determined by these quadrants. So the line at which the horizontal plane and the vertical plane, they meet is called horizontal reference line, which is denoted by XY. You can see this is the line which is called XY. So this is X and this is Y. And this we even call as a hinge line basically. Why? Because one set of projection, that is front view, will be obtained on vertical plane, top view will be obtained on the horizontal plane. Now these two views, they are obtained on a mutually perpendicular plane, but I have to draw it on a 2D plane, that is my drawing sheet or my computer screen. So if I have to draw both of these things on my single plane sheet, so what I'll have to do, the projections which are obtained on the vertical plane will stay in its position because they were obtained straight away, whereas the the projections which are obtained from the top, they were obtained on the horizontal plane, which is at 90 degree to the vertical plane. So this horizontal plane will be rotated clockwise. So in the first and fourth quadrants, this portion of the horizontal plane will be rotated downwards, that is clockwise, whereas if the projections are obtained in second quadrant or the third quadrant, then this portion of my horizontal plane will be rotated upward, so that both the projections, that is front view and top view, can be represented on a single plane or in a single plane or a single piece of paper. So the line at which the vertical plane and the profile plane meet, it is called profile reference line, and again it is a hinge and it is denoted by x1 y1. So here you can see this is my second reference line. x1 y1 means that this is a line which is the intersection of the vertical plane and the profile plane. Now here you can see what are the projections which are obtained on the profile plane when I am going to look at this object from the side. If I am looking at the object from the side, I obtain projections over here which are called left side projections or right side projections. But again, they are perpendicular to the projections which were obtained on the vertical plane. But I have to draw all the three projections on the same piece of paper or in a single plane. So for that, again treating this to be a hinge, please see, we have to treat this to be a hinge. So this profile plane will be rotated in this direction. So you can see one projections I have obtained over here, that is front view on the vertical plane. Second set of projections I have obtained on the horizontal plane, which was perpendicular to the horizontal plane. So what I'll do, I'll rotate this horizontal plane downward over here and upward over here, so that I can draw both of these front view and top view onto the same plane. Similarly, the third set of projections which are obtained as a side view on the profile plane, but again this is perpendicular to both of these. So again I am going to rotate this through this hinge, through this reference line, and once I rotate it, so vertical plane, horizontal plane and profile plane, they will all be falling in a single plane, and this way all the three projections I'll be able to project onto the single piece of paper or onto the single plane, that is even my computer screen. So this way the rotation of the horizontal plane is required, rotation of the profile plane is required to obtain all the three views in a single plane. So here you can see this is my xy, this is my x1 y1. Now we have discussed about three planes. One is horizontal plane, this is my first reference plane. Then the second reference plane is my vertical plane, and the third reference plane is my profile plane. But usually we are drawing only two views, that is front view is drawn on the vertical plane and the top view is drawn on the horizontal plane, and these two planes, they represent the primary planes and we call them principal planes. So we need to remember that the two planes out of these three, they are the principal planes. What are those principal planes? The principal planes are the horizontal plane and the vertical plane, and this is the third plane which is the profile plane, and this is a plane which is obtained perpendicular to the vertical plane as well as perpendicular to the horizontal plane. So profile plane, basically it is a plane which is perpendicular to both HP and VP, and whatever image will be obtained over here, again this has to be rotated in this direction. But profile plane, whatever image we obtain, the same things, they are already derived on either front view or the top view. So since this whatever view will be obtained on profile plane, it will be more of a derivative plane, which will facilitate us to view the image of the object in the side view. But usually we are going to require front view as well as the top view of the object. So profile plane, we need to remember the information over here is derivative or even duplicate. So this plane is not called a principal plane. So that is why we have mentioned over here that principal planes are only horizontal plane and vertical plane. And we need to remember another thing very, very carefully, that whichever view is obtained on the vertical plane, it will be obtained only when I am looking at this object. So let us assume an object is lying in the first quadrant. When I am looking at this object from the front side, so since the front viewing of the object is there, the image of the object which is obtained, or the view which is obtained on the vertical plane, this is called front view. And another technical name of this front view is also called elevation. So elevation and front view, they are synonymous terms, and these refer to the views or the image of the object which is obtained on the vertical plane, and the representation of these object points will be a dash, b dash and c dash. So if in any image or if in any technical drawing, if we provide you with an object image or the view where a dash, b dash, c dash, d dash is written, so automatically and synonymously you need to understand that it represents the front view or the elevation of the object, and this view has been obtained on the vertical plane. Similarly, the top view is whenever we are looking at the object from the top. If we look at the object from the top, so whatever view will be obtained on the horizontal plane, this will be called top view. And another technical name of this top view is plan. So the top view or the plan of the object will always be obtained on the horizontal plane, and the technical representation of this will be A, B, C, small a, small b, small c. So we are not going to tell you that whether it is an elevation or a plan or a side view. The moment we write A dash, B dash, C dash over here on the vertical plane, it means it is a front view. The moment we put down the alphabets A, B, C on the top view on HP, it means we have drawn the top view. Similarly, whatever image is drawn while we look at the object from the side onto the profile plane, so any image or view which is drawn on the side view will be represented by A double dash, B double dash and C double dash. The moment we put down these terms A double dash, B double dash, C double dash, automatically we need to understand this is a side view. So this is the 3D representation of horizontal plane and vertical plane, giving you the basic idea about the different quadrants. So the first quadrant, second quadrant, third quadrant and fourth quadrant. So you see, if we look at the object from the front, whatever view is obtained on the vertical plane is called front view. Similarly, if we look at this object from the top on the horizontal plane, so whatever image of the object is obtained on the horizontal plane will be called top view or the plan. And since these two views, they are obtained on the mutually perpendicular planes, we need to bring them in the same plane, because we cannot draw these two planes onto our drawing sheet, because our drawing sheet is a two-dimensional sheet. Similarly, our computer screen is also two-dimensional. So this will stay in its position because this has already been obtained straight away. So since this is there in the mutually perpendicular plane, I am going to rotate it clockwise. Any projection which is obtained on this side of HP will be rotated clockwise upwards, so that we can get same thing onto the vertical plane. And if we look at this from the side, so this is the 3D representation of the quadrants. So same thing we can obtain a 2D representation of the quadrant. So here you can see XY line will converge to a point. So this is my HP, this is my VP. So this is VP, this is HP, this is first quadrant, this is my second quadrant, this is my third quadrant and fourth quadrant. So this is how, if we want to use 3D representation, we'll use this sort of an infrastructure. If we are going to use 2D representation of the quadrants, so we are going to use this type of the nomenclature. So here again, HP will be rotated in first and fourth quadrants downwards, and HP will be rotated in second and third quadrants clockwise upwards. So this is once again 4 quadrants, and this I have already explained. When the object or point will be there in the first quadrant, in the first quadrant the object will lie above HP and front of VP. In second quadrant the object will lie behind VP and above HP. In third quadrant the object will lie behind VP and below HP. In the fourth quadrant the object will lie below HP and in front of VP. So this is the criteria to decide in which quadrant the object will lie. And again, always rotations we are going to see. HP will be, this portion of the HP will be rotated clockwise downwards, and this portion of the HP will be rotated clockwise upward. So this is again the same representation. So here you can see this is my horizontal plane, this is my vertical plane, and this is my profile plane. So if I look at the object from the front, The view on VP is my front view, which I have drawn over here. This is my hinge, my XY line. You can see this is my XY line. My XY line is the hinge. So what I am going to do, front view or the VP will stay in its position. Top view or HP will be taken downwards. This portion, that is first and fourth quadrant, it will be taken downwards. So the top view will be drawn below the front view. And if I am going to look from this side, I am looking at the object from the left side. So the view obtained onto the profile plane will be the left side view. And again, X1, Y1 is my second hinge. You can see this is the second hinge over here. So two hinges I have shown. One is across XY, another one is across X1, Y1. And the moment you rotate it, now you can see front view, top view and left side view I have drawn on the same plane, 2D plane, or my computer sheet. So these three views, they were obtained on mutually perpendicular planes, but through appropriate rotations we have ensured that all these three views, even though they were obtained on the mutually perpendicular planes, they have been drawn onto the same plane. So here you can see this is one of the multi-view orthographic projection where front view is obtained here, top view is obtained in the mutually perpendicular plane. This is HP, this is VP, and this is my profile plane. So profile plane is rotated like this, horizontal plane is rotated clockwise downward. So you can see we have been able to obtain all the three views, front view, top view and left side view, onto the same 2D piece of paper in a single plane or onto my computer screen. So the benefits of the multi-view orthographic projections, they give you the accurate representation of shape and size, but obviously because multiple views they are drawn, so proper knowledge and understanding will be required. So again, you can see we have drawn two views over there. One is the front view and another one is the side view. Now let us see why we do not draw projections in the second and the fourth quadrant, and let us see when the object is located in first quadrant how the projections will be obtained, when the object is located in second quadrant how the projections will be obtained, when the object is located in the third quadrant how the projections will be obtained, and similarly when the object is obtained in the fourth quadrant, so how the projections can be realized. Now these projection planes, now we are going to treat them, these are our planes of projection or reference plane, and we are going to treat them as opaque or transparent depending upon our requirement, that we should be able to obtain the image or projection of our object onto these planes. So in certain cases you can see that we are going to treat these planes as opaque, or in certain cases we are going to treat these planes as transparent. So I'll just explain how do we decide that whether this plane will be opaque or transparent. So in the first quadrant, you see, as I have told you, that the projections which are obtained when the object lies in the first quadrant, they are called first angle projection. And when the object will lie in first quadrant, when it lies above HP and in front of VP. So let us have an object. So this is a cube which we have taken and assumed it to lie in the first quadrant. So you can check, this object lies above HP and in front of VP. So depending upon this distance that it lies above HP and in front of VP, I am going to get the construction of two squares over here. If I look at this object from the front, you can check. If I am going to look at this object from the front, this cube will appear as a square onto this vertical plane in my front view. If I am looking from the front, the image of this cube on the vertical plane will appear as a square in the form of a front view or the elevation. And if I have to do the marking, A dash, B dash, C dash, D dash I can write. But right now I am only bothered about showing you the shape of the image or the projection. So this is my shape which is obtained above the XY line. Please check. This is my hinge or the XY line. So this will be the distance that this cube lies above my HY line. So this distance will be equivalent to the distance which my object or the cube lies above my horizontal plane. Similarly, if I look at this object from the top, So the image from the top, the projection lines will be coming, and all these projection lines, they will be focusing upon this horizontal plane wherever they intersect. This will give me the formation of another square. And what will be this distance from this xy line? Whatever is the distance of this cube in front of the vertical plane. So I have obtained two squares. One is the front view, another one is my top view. But unfortunately, both of these, they are in the mutually perpendicular planes. And in this case, I have assumed my planes of projection to be opaque. Why? If they are transparent, my image will not be formed. So I am looking from this side, object is here. If these are opaque, only then the image will be formed over here. So this is also opaque. I am looking from the top, object is here, my image is formed over here only when this is opaque. So both of cases I have treated these reference planes to be opaque, but I have obtained two projections, front view and top view, in mutually perpendicular planes. So how I can bring them, both of them, into the same plane? I will be rotating this. You see, vertical plane projection will stay in its position because it has already obtained onto the vertical plane. Straight away whatever I am able to see. But this is perpendicular to my view of projection from the front side. So what I'll be doing, I'll be rotating this horizontal plane downwards clockwise. And once I rotate it across this hinge, so front view will be coming above xy line and the top view will be going below the xy line. So here you can see, this is how I will be able to draw my front view and the top view. You see, I have rotated this. I have rotated this horizontal plane. I have shown this rotation. And then once I draw, this is my xy line. So the distance of the object above the xy line will give me this square. And the distance of the object in front of the vertical plane will give me this distance. So this distance is equal to the distance in front of VP. This distance or this distance is the distance of this object above the horizontal plane. So I have been able to obtain both of these views, that is front view on vertical plane, that is the elevation, and my top view or the plan onto the horizontal plane in a single piece of paper, that is in a single plane. How is it possible? Because of this rotation. So in the first quadrant, the front view, we need to remember, the front view will be drawn above the xy line or my reference line, and the top view will be drawn or the plan will be drawn below the xy line. And you can see both of these views, they are unique. They are not interfering with each other. So since the views, they are unique, so this is the acceptable method for drawing the engineering projections of any given object. So the front view, it lies above the reference line. Top view, it lies below the xy line, but both of these, they are unique, non-interfering. It gives us the clear visualization of front as well as the top views. Now let us move on to the second quadrant, that is second angle projections. And I have already told you that we do not draw the second angle projections, and reason I'll just explain. So when the object will lie in second quadrant, when it lies behind VP and above HP. So you see, here is my object. Now I have assumed this plane to be transparent and this one to be opaque. Now the reason is quite obvious. If this plane I treat it to be opaque and the observer is located over here, if the observer is located, had it been opaque, it would have been just like the object lies across the wall. If the object is lying across the wall, you cannot see through what is happening across the wall. So we are assuming that this wall or the reference plane is my transparent plane. So my object will be viewed upon by the observer from this side always. And once I look at this object through this plane, the rays of sight, it will touch here and it will go back to this particular transparent plane so that I can get the image of this object onto this intermediate plane. And this will happen only when I am using the transparent reference plane, that is my vertical plane. So you can see I am looking from this side, front side, object lies across the vertical plane. So the vertical plane is treated to be transparent. So the image of this object will be obtained on the vertical plane in the form of a square. And how much will be this distance? This distance is equal to the distance which this object is above my horizontal plane. Similarly, now I look at this object from the top. When I look at this object from the top, now I can assume it to be opaque, because if this is transparent, my rays of sight will go beyond this. So if this is opaque, the observer, object and image will be obtained on the reference plane. So once I look at this from here, so this is the object, whatever rays of sight will be there, they will be falling upon the object and then they will merge onto my projection plane. Again I'll get a square. Now how much is this distance from the xy line? Whatever is the distance of this object from the vertical plane. So distance of the object from the vertical plane will decide this distance. And then you can see these are the lines which show the relationship between front view and the top view, and these lines, they are called projection lines or my construction line. Now one view I have obtained on vertical plane, which is straight away, it will stay in its position, but another view I have obtained on horizontal plane, that is top view. But again both of these views, they lie in the mutually perpendicular planes, and I have already told you in first quadrant and fourth quadrant HP will rotate downwards, that is clockwise. In second and third quadrant my HP will rotate upwards, that is again clockwise. Now you see two views, they have been obtained in mutually perpendicular planes, but my drawing sheet is a single plane, that is my computer screen. So I have to again rotate this so that both of these views I can obtain on a single plane. So what I am going to do, just see, I will rotate it. I have enlarged this arrow, that is rotation, and I am assuming over here that the distance above HP and distance behind VP is same. If the distance above HP and distance behind VP is same, both of these views, they will merge with each other. So what I'll be doing, I'll be writing A, B, C, D for plan and A dash, B dash, C dash, D dash for elevation. All these points, they have merged. It is an interfering view, and even if the distances I would have taken different, then this situation would have arisen over here. If the distances are different, still the views would have been intersecting. Whichever view is located at a larger distance will be appearing on the upper side. Whichever view is located at a shorter distance from the VP or HP, it will be located slightly at a lower distance. So whether the distances, they are same, they will be perfectly overlapping. If the distances of the object from HP and VP, they are different, so depending upon the distance, either front view will be above the top view or the top view will lie above the front view. But still, these views will be intersecting, and more the views they are overlapping or intersecting or interfering, the clarity obtained will be much lesser. And since the views obtained in the second quadrant, they overlap with each other, they interfere with each other, they lead to lesser clarity regarding the proper apprehension of both of these views. So that is why projections, they will not be drawn in the second quadrant. So here you need to remember, in the second quadrant, front view will lie above HP and the top view will also lie above HP. You can see front view will lie above HP and this top view will lie again after rotation, after the rotation above the XY line. So front view and top view, both of these views, they lie above the XY line. So leading to overlapping or interference and reduction in the clarity. So we don't draw projections in the second quadrant. Then in the third quadrant, my object will be lying below HP and behind VP. So if my object lies below HP and behind VP, and once again, I am going to look at this object from this side, from the front side. So here you see, I am looking at this object from the front side. Now if I treat it to be opaque, now again this will be a case of an object after the wall, beyond the wall. You will not be able to see the object. So if you have to see the object, this wall or the reference plane has to become, plane of projection has to become transparent. So this plane will be assumed to be transparent. Once I am looking at this object, now the rays of sight, they will fall over here. Again, they will project back one square I will be able to see over here. So projections will come and they will fall back. So I will get this as my front view because I am looking at this object from the front. Similarly, I want to look at this object from the top. So here you see I'm looking from the top. Again, if I treat it to be opaque, so obviously again this will be case of object behind the wall. You'll not be able to see it. So you are looking from the top, the plane is transparent, the rays of sight, they will form an image. Again a square is obtained, but again the front view and the top views which are obtained on vertical plane and horizontal plane respectively, they are there in mutually perpendicular planes. So we need to bring them onto the same plane. So this is obtained straight, so no need to change this. This view is obtained on mutually perpendicular plane. Obviously, as discussed earlier, these are my reference guidelines which establish the relationship between front and top view. I am going to rotate this horizontal plane clockwise upwards. So once I rotate it, you see I have enlarged this, and then the front view will be drawn. This is my XY line. The front view will be drawn below XY, and the top view after rotation, this will be going above my XY line. So this is just inverse to what I had obtained in my first quadrant method. In the first quadrant, my front view was above the XY line and top view was below the XY line. Whereas in the third quadrant, my front view lies below the XY line and my top view lies above the XY line. But again, the beauty of this third quadrant projections is that both of these projections, they are independent, they are unique, they are non-interfering. So that is why we usually study projections in first quadrant as well as in the third quadrant. So in the third quadrant, the front view lies below XY line and top view lies above XY line, which is just reverse of the first quadrant projections. And in the fourth quadrant, when the object will lie in fourth quadrant, when it lies below HP and in front of VP. Again, you can see my object lies below HP, front of VP. And once again, if I am looking at the object from the front, so this plane will be treated to be opaque because the image has to be obtained onto this vertical plane. So this is opaque. And if I look at the object from the top, again, it has to be assumed transparent because this image has to be obtained on the horizontal plane. Now let us look at this object from the front. Look at the object from the front, image is obtained. Look at the object from the top, image is obtained on HP. But again, front view which is obtained on VP, it is mutually perpendicular to the top view which is obtained on HP. But this is obtained in the front view, that is looking straight. So it is not to be tampered with, whereas this view is mutually perpendicular to the front view. So this will be rotated downward. If I rotate it downward, again you can see there will be overlapping of front view and the top view. And again, if I assume that this distance from HP and from VP, if they are equal, once again it will lead to complete merger or overlap of front view and the top view. So again, complete overlap. If this distance is equal to this distance, what is this? Distance of the object in front of VP and the distance of the object below horizontal plane. If they are equal, they will overlap. And if the distances, they are unequal, so depending upon whichever view is at a larger distance, that will be drawn farther away. Whichever view is at a shorter distance will be drawn at a lesser distance from the XY line. So your front view can be farther away or your top view can be farther away from XY line depending upon the mutual distance. Whichever view will be at a larger distance from the XY line will be drawn farther away. But whether you have the perfect overlap or you have the partial overlap, again you have the infringement in the overlaps. So there is huge interference leading to reduced clarity of the views. So that is why you do not draw projections in the fourth angle quadrants as well as the second quadrant. So the difference between fourth quadrant and second quadrant is, in second quadrants both of these views, they were obtained above the XY line, whereas in the fourth quadrant both these views, they are obtained below the XY line. So that is the difference between second and fourth, they are opposite, first and third they are opposite. So this is the summary. In first quadrant, the elevation or the front view is drawn above xy, plan is drawn or the top view is drawn below the xy line. In second quadrant, both of the views they are drawn above. In third quadrant, front view is drawn below the xy line and the top view is drawn above the xy line. In the fourth quadrant, both of the front as well as the top view they are drawn below the xy line, and this is what we have obtained. And since we have discussed, because of the serious infringement and overlap and lesser clarity in the second and the fourth quadrants, because of the views they are interfering with each other, so projections they are never drawn in second and fourth quadrants. We usually draw projections only in the first as well as the third quadrants. Now we are going to discuss the second projection theory, that is based upon whether the object lies in the first quadrant or the object lies in the third quadrant. So we already understood how the projections they are drawn in first as well as in the third quadrant. So we have understood that in the first quadrant, front view lies above xy, top view lies below xy. So this is the example which we have already drawn. In the third quadrant, top view lies above the front view, so that is front view lies below xy and the top view lies above the xy line. So we can say that in the first angle projection method, the front view lies above the top view, whereas in the third quadrant the top view lies above the front view. Now we are going to discuss about the symbols of the first angle as well as the third angle projections. So please see, in first angle the object lies above HP and in front of VP. In third quadrant, it lies below HP and behind VP. So these are the symbols. So you see, if this is my object, this is my tapered cone or my truncated cone, this is called frustum of a cone, tapered cone, which has been cut. Now if the observer is looking from this side, please check, observer, object and plane of projection. This is what used to happen in my first angle projection. Observer is there, then the object is there, then my plane of projection will be there. And if I am looking from this side, this circle I will be able to see, this circle also I will be able to see. So two circles are there and the center lines I have drawn. So this picture will be obtained or this view will be obtained only when I am looking from this side. So this conforms to the first angle projection, that the object lies between observer and the plane of projection. Again I repeat, in first angle projections, the object lies between observer and the plane of projection. So this projection will be obtained. So this is my observer, this is the plane of projection and the object lies in between. Now the projection theory says that the symbol or convention of the third angle projection is, we have just changed these two things. So I am looking from this side, observer is here, the plane of projection which was assumed to be transparent lies in between, and here lies my object. If I am looking at this object with my intervening plane, through my intervening plane, so you see, I'll be able to see this circle clearly onto this plane, I'll be able to see this circle onto this intervening plane. So if I draw this symbol, it means that I am talking about first angle projections. If I am talking about this symbol, it means nobody is going to tell you whether it is a first angle or a third angle. You need to remember, this picture will be created when the observer is looking at this object from this side. So object lies in between my observer and the plane of projection. Here my plane of projection lies in between my observer and the object. That is the distinction between first and third angle. In third angle projections, my plane of projection used to be lying intermediate between my observer and the plane and my object. So this is the symbol of my third angle projection. So this we have already discussed, first angle projections. This is my front view, this is my top view. I am looking from front, I'll get this view above the XY line. I am looking at this object from the top, I get this view on the horizontal plane, and this will be rotated downwards. And if I draw it onto the same plane, this will be my front view which is drawn above XY on the vertical plane. This is my top view which is drawn on HP below my XY line. And in first angle, object lies above this HP and in front of this, and again my object lies in between the observer and my plane of projection, and my front view lies above the top view. And let us see the examples of the first angle projections. So just check. I'm looking from the front. My front view is obtained on vertical plane. I'm looking from the top. My top view is drawn on the horizontal plane. I'm looking from the left side. My left side view is obtained on the right hand side, and this will be rotated in this way. This will be rotated downwards. So this is my profile plane on left side. Similarly, if I look at this object from the right hand side, there will be another profile plane over here. Similar to this plane, I will have another plane. And just like we had hinge x1, y1 over here, another hinge x2, y2 will be lying here. And this plane will be rotating in this direction. So another projection I can draw right side view as well. So here I'll just show you. Front view comes above xy, top view comes below xy, left side view is obtained on the right hand side, and if I look at this from the right hand side, another picture plane, profile plane will be here with hinge located here, and this will be rotated in this way. So this will be rotated this way, and my right side view will be obtained on left hand side. So I need to remember front view above xy, top view below xy, left side view on right hand side, and if you look at the object from the right hand side, right side view will be obtained on left hand side. So this is the convention for my first angle projection. So these are few examples. If this is the object, you look at this from front, this is the view. Look at it from the top, you see this portion, you can see this correction or the niche you cannot see. So that is why the dotted lines are there. You look at it from the side, left side you see view is drawn on the right hand side. So one square and one rectangle you are able to see. Front, top, and on profile the left hand side view is drawn on right hand side. Another view, this is the object. You look at it from front. So this is front view. Look at this from top, below xy. Look at it from left hand side. You can see it is drawn on right hand side, and from left hand side, please check. You can see this rectangle, you can see this rectangle loud and clear. So both these rectangles, they are drawn dark. But you look at this object from the right, you can see this complete surface over here, but this niche or this cut you cannot see. Since you cannot see this cut from right hand side, so this line has been drawn dotted. So right hand view has been drawn on the left hand side with this cross section has been shown dotted over here. If you look from left, this will be visible. You look at this object from right, this edge will not be visible. Now similarly, third angle projection, we have drawn the symbol. In the symbol, this is the plane of projection which is lying in between the object and the observer. So please check. In the third angle, I have my object over here. Plane of projection in either case is intervening or intermediate, which is transparent, and my observer will lie over here or over here. If I am drawing front view, my observer will lie over here. If I am looking at the top, so my observer will lie over here. You're looking at the front view will be obtained on the vertical plane. You looking from the top view will be obtained on horizontal plane. Both are mutually perpendicular. This will be moving upward. HP will be moving upward. Just you can see the arrow. This is the arrow, and then front view is drawn below the XY line and the top view is drawn above the XY line. So this is my third view, and in third angle, please check how the projections they will be made. There is a difference. The front view is drawn below the XY line. So this is the front view. This is my HP. So this gives me my XY line. The front view will be drawn straight. This is the top view which I am showing you right now. Now the front view, again, this is the intervening plane. So this is intervening plane for the top view. This is intervening plane for my front view. In third quadrant or third angle projection, plane of projection lies between the observer and the object. This is object, this is observer, this is the plane. This is observer, this is the object, this is the plane. So I obtain the front view below, and this will be rotated upwards. So the top view will be coming above. But please see the change. In the earlier case, the two left and right side views, they were drawn above. But since they were drawn besides the front view, this thing we need to remember. They were drawn above. Why? Because the front view was drawn above. But in this case, the front view is drawn below the XY line. So the left side view and the right hand side views, they will be also drawn alongside the front view below the XY line. Now you can see another difference. If you are going to look at this object, you see from the left hand side, again there is an intervening plane. In third quadrant, always there will be intervening plane. You are looking at the object, this is the object, intervening plane, and this is the observer. The image of the object will be obtained here, not on this side. It will be obtained on this side. The image which is obtained on this side, this is my hinge, x2, y2. I will open it out this way. So whatever image of the object is obtained on left hand side, this hinge is over here, this will be rotated here. So the left side view will be drawn on the left hand side. Whereas if I look at this object from the right hand side, this is my intermediate plane, this one. This is my intermediate plane. So this will be my observer, intermediate plane, and then the object. So image of this object will be obtained on the intermediate plane, which is lying here. And the hinge will lie here. And this hinge will open out on this side. So since hinge lies here, so the side view will be rotating, right side view will be rotating on the right side. So right side view will be drawn on right hand side, left side view will be drawn on left hand side, and front view will be drawn below XY, and top view will be drawn above XY. So this thing we need to understand. This is my left side view which is drawn, and it will be opened up on this side. Okay, so here you can see all these views, right? So three views, let us see how we can draw them. This is my object which is assumed. You can see this symbol. So symbol shows that observer is here, plane is here, and the object is here. So observer, plane, object. So the front view of this object will be drawn below the XY line. I am considering this as the front. So front view is drawn below the XY line. The top view of this object, this is drawn above the XY line. And this is, now I am looking at this object from right hand side. If I am looking at this object from the right hand side, whatever image is obtained on the profile plane, there will be an intermediate plane over here. And this will open out this way. So right side view will be drawn on the right hand side of the front view. Had I drawn the left side view, so left side view would have appeared here in the intermediate plane. It would have opened like this, so it would have been drawn on this side. So left side view on left side, right side view on the right side. Whereas in the first quadrant, left side view was obtained on the right hand side of the front view, which was drawn above the XY line. Another example, here you can see the notations. So the notations I have already given you. Whenever you draw the top view or the plan, the notations of point A will be A, or if it is a line, it will be AB. If multiple points are there, the notations will be small a, small b, small c. If you are going to draw the front view, the notations will be small a dash, b dash, c dash, like that. And if you are going to draw the side views, the notations will be drawn as a double dash, b double dash, and c double dash. So with this, we have completed the discussions regarding the different methods of projections which are used in the engineering drawing. So I hope you might have understood the basics of the projections used in the engineering graphics. Now we are going to start with projection of points, projection of lines in the next lectures. So thank you very much. I hope you have really understood the basic principles of the projections. So thank you very much.